Okay, so we're continuing with methods of partial fractions, and this is part two, introduction part two. Again, we're starting with a quotient, and we make sure in the first step, we make sure that to divide it to get the degree of the numerator less than degree of the denominator. Then we factor the denominator into linear and quadratic with non-real solutions. I may have in the first video said complex solutions, but complex solution contains the real numbers too. I mean these quadratic ones should not have a real solution. And so basically only non-real complex numbers. And then the next step is to try to, if you remember from the first video, we want to break it down into those nice integrals, and therefore to be able to do that, what we need to do is to break down the fraction into fractions that add up to that fraction. Basically, this is going to be the opposite of adding fractions, common denominator, doing whatever you're doing. This is the opposite of that. You want to make it simple. Let's say you had 1/2 plus 1/2 and it ended up, or 1/4 plus 1/4 and you had 1/2. Now if I give you 1/2, I kind of wanted to ask you to basically break it down into two polynomials that are of the simplest form, basically two fractions that are of the simplest forms. Now here, how does this work? And as far as that, so the format, let's say the denominator is however we explain it. We want to write a of x over b of x, so that basically for every linear factor, let's say for every a1x plus b1, we want to have and let's say capital N1 plus capital N2 over ax plus b1 to power 2 plus all the way to, if you remember, the first one we factored looked like this. To power n1. So basically, if the linear factor is of power n1, you want to have n1 many fractions with all the degrees of a1 x plus b1, and then the numerators are going to be all constant. And the same thing for all the other linear factors. And then also for every quadratic ones that have no real solution, you will get, let's say, c1 x squared plus d1 x plus e. And you want to have in the numerator, you want to have let's say P, O, P, Q, R, let's say S, S1X, T1, and plus S2, X plus T2, if this quadratic one comes in the higher degree, and so on and so forth, all the way to whatever the degree is, that many, as many as the power is. And so when you basically add all these fractions, you will get the same thing as b of x, and then you're supposed to get the same thing as in the numerator, you're supposed to get the same thing as the a of x. And then the last step is of course using that the last piece of information, that you know how to integrate using using this formula. Dx by u substitution, or c over c1x squared, or let's say, yeah, plus c2x. Yeah, c2 is okay, plus, let's continue using the same routine as that, c1 x squared plus d1x plus e to power m dx, using basically tricks up with arctan. So yeah, that's the overall feeling of it. This was very general explanation of how things work. The next that we do, we give concrete examples. Then we start with the simple ones, and we give instruction for the simple ones. But always remember the basically the overall, for you can do this for any polynomial and any quotient function, basically. And so the most of this emphasis sits on this part, on how to solve these coefficients, because the coefficients of the numerator are going to be unknown to us. Everything else, you know, coefficient of the numerators is going to be unknown to us, unless you know how to do the method of the partial fractions. You have to learn how to do those, basically. And the existence of such things, this is some linear algebra problem that you can find in linear algebra books, basically, how to solve for these coefficients a little bit. But I mean, how the existence, they all exist, basically. This dividing the, or not dividing, but writing a quotient into sum of quotients as possible. So let's go back to the simpler form.